Hello and welcome. So, given the triangle below, solve for x, then state the side lengths of the triangle. All right. So first thing we notice here is what kind of triangle are you looking at? All right. Look at the information you're given. We have three different sides that are given to us, and we also see this little notations for angles in the corner. Now, because these all have that single little angle and not like double on one of them or triple on another, that means that all three of these are actually the same angle. They are all congruent to each other. And if you have three congruent angles in a triangle, this guarantees them to all be 60 degrees. And when they're all 60 degrees, you're then guaranteed to have what's known as a equilateral triangle. All right? And once you know that, then you also know that all of the sides are congruent to each other. Yes. Okay. So, first thing we figure out is now that we know all the sides are congruent, they're all equal. That is a relationship, and you can set up an equation to solve for x. All right. Now we have three sides. You're like, great. Well, usually you write an equal sign with one on each side. Don't need three things. So, doesn't matter which two sides you pick. Answer: no, it doesn't. You can make an equation with 6x plus 35 equals 9x plus 14. Or you can solve for x using the 11x equals 6x plus 35. Or you can set up the 11x equals 9x plus 14. Or you can set, like, honestly, you can run this any direction you want to, right? As long as you pick two of the three sides, you are good to go. All right, I'll just keep with this first one because I wrote that first. Why not? Okay, so first thing I do if I want to solve for x, I want to get all the x's on one side, all of the numbers on the other. So I'm going to subtract 6x because I like my variables to be positive for literally no other reason. I'm also going to subtract the 14 in the same step, so that'll cancel the 14s and the 6x on both sides. And you're left with 21 equals 3x. 35 minus 14, 21. 9 minus 6, 3. Alright, and then you would just continue solving from there. So then you would undo multiplication with division. So you would divide 3 on both sides, and we get x to equal 7. Done. Solved. Okay, now you need to double check your answers, which, actually works out in any. Yeah, actually works in your favor because you want to make sure that your solution's valid. So you would just check, right, and plug it into each one. So we have 11 times 7, which equals 77. Okay, that's a positive number. It'll work out. Okay, next one we have 9 times 7 plus 14. 9 times 7 is 63, plus 14 gives you 77. Yay! Works out. Okay, last but not least, we have 6 times 7 plus 35. 6 times 7, 42. Plus 35, 77. They're all positive numbers, which means 7 is a valid solution. And more than that, you'll notice that all of them are equal. Wow. My, what a coincidence. No, as it happens, it's not. Because it's an equilateral triangle, all three sides are the same. Alright, so you literally just verified that it was an equilateral triangle, and you actually could have known that they were all 77 simply by plugging in 7 to any of the sides, and you would have known all of them were the same. Fun facts. Alright, thank you so much for watching. That's all there is to this one.